Hi everyone, and welcome to our video on finding the future value and present value when we have interest that is compounded continuously. So we have an old formula from exponential growth and decay right here. Well, when things are compounded continuously, so when we're dealing with compound interest that is continuous, this formula is the same formula that we would use when we had any type of exponential growth. And so when we graph it, so that's our t, and then here's our y-axis, which would be capital P, and our exponential function would do something like this. And we would have P naught on the y-axis at that point, and then as it grows exponentially, it makes this exponential curve, where P, that is the future value, but they might call it P of t. Okay, so the future value at time t. P naught would be the present value. Okay, so that would be when t is equal to 0. So t naught is t equals 0. Okay, so t naught and t equals 0 are the same thing. And then e's are e, the 2.71, and then k is the interest rate. And we should convert it to a decimal when used in the formula. Okay, so decimal in formula. And then t is the time in years. All right, so on this it says find the future value P of the amount P naught equals 300,000 invested for T equals 5 years at interest rate K equals 5%, compounded continuously. All right, so it says find the future value P, and I wrote P of T, but we can change it to be P. Let's do it for this problem. Okay, so I've got P equals P naught e to the KT. And it tells us what all of our values are. So it's saying find the future value. So it will be P equals. They're telling us P naught is $300,000. So there's 300,000. And then E to the K. So it's 5%, but in our formula, we should change it to be 0.5. And then we'll times it by T, which in this problem is 5 years. Okay, so there's the whole setup. And then we could enter this all in one big step in the calculator. So there's my 300,000. Oops, I guess I don't need to rewrite it. Let's just enter it. So I've got my calculator ready. So when we plug it in, I'm just going to use Desmos. So 300,000 and then E to the, now you might need parentheses on this part. So it's 0.05 times 5, like that. And then that is our final answer. Well, you usually round it to the nearest cent. So we would do $385,207. $385,207. Oops. $207.63. Okay, so that's it. There it is. So we just entered it into our calculator. So for instance, if we had a bank account and we had $300,000 invested in it, and we had the same interest rate and it was compounded continuously in 5 years, that's how much it would be worth. Okay, so it'd be worth $85,000 more. All right, so let's see how we can solve for present value. So find the present value P naught of the amount P equals 40,000 due T equals 4 years in the future and invested at an interest rate of K equals 4%, again, compounded continuously. All right, so I'm going to write my formula again. P equals P naught e to the KT. And then we're just plugging these in again. So the future value P naught, given P equals 40,000. So we have 40,000 equals P naught e to the K, which is 0.04, and then times T, which is 4. Okay, so there's our big setup. Now the difference in this problem versus the last problem is I need to solve for p naught here on the right side. So that means we should just divide this exponential over. Now in this problem, I am going to multiply that 0.04 and 4 to get 0.16. And then I'm going to divide this e to the 0.16 on both sides. So we'd have 40,000 divided by e to the 0.16. Okay, so that way I can still just plug it in one clean step in the calculator. And when we do, so we'll have 40,000 divided by e to the 0.16. There we go. Okay, so we have $34,085.75. $34,000. $34,000. There we go. $34,085 and then 75 cents. Okay, it's just trying to memorize all those numbers from the other screen. There we go. Okay, that's it. Okay, so that is the present value of that amount. Okay, so it's just kind of working backwards. So like if we wanted $40,000 in 4 years at this interest rate, we could invest $34,000 into that account. All right, but that's that. Okay, so it's just using the formula. So chances are, so when we have compound continuous in banking, that's kind of actually unusual. Usually it's compounded like monthly and we do it a different way, but this is still fine. All right, so if it is compounded continuously, these are the final answers. So we're usually finding present or future values. Some problems you might have to find K or T. Okay, and we would have the other values and plug them in and we can find them. Okay, but most likely it's just these two. Okay, so anyway, that's it. Thanks for watching. If you have any questions, please let me know.